Hello and welcome to our webinar, which is a video cast today. I'm Gene Tyndall with Hopkins International, and with me is my friend and colleague Doug Kane with One Network. We're happy you tuned in today because we have a very important topic to discuss. It's reducing lead times, or as we will refer to it as data latency, the silent killer for supply chains. We wanted to design this especially for consumer electronics companies because of the special needs of the supply chains of this product. It obviously will work, as you will see, for any consumer products company that sells, especially through retail. You know, there's a lot of issues out there around supply chain effectiveness, and one of them is indeed time. Everybody wants more speed today. We see things like speed to market, speed to benefit. I even saw one recently, time to insight. So the question is, how long does it take to get some insight out of big data or something like that? So really is a lot of interest in speed, and we're going to really address that kind of issue today because it's not really been solved so well yet. I thought I'd start with the context of why this is so important and refer to the 7 top priorities for consumer electronics supply chains in this year, which we have come up with and talked about. One is adhere to the right operations strategy. Consumer electronics companies have been big innovators in supply chains over the past, but the question is now, with all the changes in the market and competition and so on, do we really have the right operational strategy to really make sure we're winners in our markets? Second is operate effective business processes with talented people. Business processes are continually being changed, as they should be, and with new information and new things and tools to work with, we do need to keep challenging our business processes. Third is integrate business planning and execution. We see this more and more because planning has become a lot better for us, but execution tends to still fall out of the game so well. It is not integrated as well as it should. And here comes 4 that we really will address today. Fourth is operate in demand-driven value networks. We talk about demand-driven because it is clearly the new way of operating your supply chains and your value chains, is making sure you know what is selling before you push out products that aren't. So we'll talk about demand-driven. Fifth is optimize logistics. You really do need the logistics of your supply chain to work in its best possible way if we're going to win in the marketplace. 6 is adopt new powerful technologies. And you'll hear about one today from Doug especially on some new powerful technology that really gets at this question of lead time, and that's part of the agenda here. And 7, proactively manage supply chain risks. You know, because too often we react to things like out of stock, or react to things that happen that we weren't forecasting. Variability and so on is very important. So keep those 7 supply chain priorities in mind as we go through our webinar, and as I said, we're going to address several of them as we go through. You know, demand-driven supply chains, as I said, is our view of how supply chains need to work in this era of the industry. Consumer electronics, consumer products, all sorts of products need to turn their mindsets around from creating a product and pushing it out there to finding out what's selling and working it back. So with that introduction, I'm going to ask Doug to drill into a little bit now about what is the anatomy of lead times and how we see lead times impacting supply chains.
Thanks, Gene. From a lead time standpoint, high-tech supply chains tend to have much longer lead times due to the fact that a lot of production and manufacturing is done in Asia, and you've got the long ocean freight time and so forth. So it's a little different than a lot of other industries, and because of that, that actually introduces a lot of different variability from the supply side, and then also from the demand side, because if you've got a 4-week time to build, put it on the ocean and get it over, the demand picture that you see a month from now may not be what it was when you were initially forecasting. So from the standpoint of lead time, the physical lead time is how much time does it actually take to go from point A to point B on a truck, a plane, a car, a truck, plane, boat, and so forth. But then the silent killer is what we call system lead time. And system lead time in a traditional supply chain, you've usually, as the name chain would imply, it's really a point to point. So you're really connected from the next person back in your chain, right? So what has happened over time is you've got this point-to-point connections, and it'll be either human interactions or some EDI transactions, some transactions going back and forth. But at each level, as you go through the chain, there's more and more system lead time introduced. And in this particular example, we show physical lead time from getting out from supplier through manufacturing and out to the stores. It's roughly 33 days of physical lead time. The system lead time, or the time it takes to actually communicate between each one of these links, is 29 days.
Wow.
Based on this particular example, we're showing lead times of roughly 33 days of physical lead time, 29 days of actual lead time. So the total lead time is actually 62 days. You start adding in buffers at each location, and all of a sudden your chain-wide inventory becomes more than 70 days of stock.
Wow.
When you're carrying high valued inventory and so forth, and combine that with short product life cycles, what typically happens is you end up in either under supply for the types of products that are fast selling, or you've got way too much of the stuff that isn't selling, that you end up having to get rid of them, or basically reduce the price and dump them at the end of the
So
life
I understand there's physical limits, or let's say requirements, or you could do air cargo and cut out some ocean time, which of course some companies do. But other than that, there is physical time that it's actually taking to move the product.
Correct.
But the system lead time, is that created by people or processes or systems that make it move from end to end?
Yeah, basically that is what we would define as the system-based lead time. So, in this example, and it's backed by several studies, that 40 or more % of a total supply chain lead time is in system lead time.
Wow.
If you can reduce that system lead time to basically real time,
Yeah.
that cuts out 29 days right there.
Mm-hmm.
In this example was at roughly 45% of the chain-wide inventory.
Wow.
So it's got significant value, and it's certainly worth considering and trying to figure out how do we get rid of that system-based lead time.
Well, I think I understand now the problem. That is, we've got a lot of this time in there caused by inefficiency, work, uncertainty, people, transactional stuff, all the stuff that goes, especially from one company to another, but even within a company, right?
Mm-hmm.
I mean, merchandising may be ordering a product, supply chain is moving it, and they're wondering who has ownership of it and all that sort of thing. So I understand that's still a problem in most supply chains, especially international ones, but even in domestic ones.
Oh, yeah, absolutely.
Okay.
Yeah, I mean, it's not, when you move it into the realm of high tech, because of those long lead times, that just increases the variability, which obviously you end up buffering against variability, and that's what leads companies to have such excess inventory, or if they're not properly forecasting, we'll talk a little bit about that, but you want to recognize what's actually being consumed and build to what that consumption is, not build to a statistical forecast that may not have any basis in reality.
Okay. Especially 70-some days later.
Well, yeah, exactly. I mean, right. We've talked about demand-driven and the importance of demand-driven, and of course, that's been on people's minds for a long time, right?
Mm-hmm.
So it means a whole lot of different things to different people. But from our standpoint, what we look at is what is the forward most consumption or point of consumption that you can gather in a systematic format. In several cases, it's the actual POS data or orders that are coming in via the web. At other places it might be at a DC level, so the retailer DC out to the store. In some cases, it's from the manufacturer or brand owner's DC out to the retailer, out to the channels. So in a demand-driven world, though, if you're forecasting out with these 5, 6, 7 week lead times, what tends to happen is if you're not looking at that actual demand, you're building to a forecast, and on one end you're filling up this, call it the floating warehouse. So you're filling up these containers with stuff that may not be relevant to what's actually selling, right? So as you can start recognizing in real time what is actually selling at that time, now you start feeding back, and once you've removed the system-based lead time, if you can communicate that back to your manufacturing partners or contract manufacturers, or the EMS providers in the high-tech world, then they can start building the right product mix, because you're going to put it on a boat and it's going to take 3 to 4 weeks to get over here. If you keep filling that floating warehouse with the wrong product, you're going to be stuck with it when it gets back out here on the other side, whether it's finished goods or whether it's in Mexico for postponement. It's still the wrong product. Now on the flip side too is, as if you recognize what's actually being consumed. So on one end, we're helping build the right product mix back in Asia. As that's coming over now, as we said, of course, the demand picture 4 weeks after this thing has been on the boat may be completely different than what you thought. And so one of the things that you want a system to do, and as you look at supply chain orchestration versus collaboration, you want enough intelligence in engines, visibility and planning and execution engines in a solution that would be able to understand, okay, where are the different points of my inventory? What do I have what does the retailer have at the store? What does the retailer have at the DC? What do I have as a brand owner, what do I have in my DC? What's on its way inbound from Asia? And then as you're consuming in real time what's actually selling, there's no reason to allocate that inventory on the boat until it actually gets here and you know where it really needs to go. So for instance, you may have a region for some reason, a region may, an Office Depot might have just completely sold a whole bunch of HP products, right? Yeah. Well, it was completely unforecasted, and 4 or 6 weeks ago when they were building that, they had no idea. Yeah. Well, real time in a demand-driven value network, they can start seeing that inventory and they know they've got a problem here, and they can make those deployment decisions, delay those deployment decisions until the very end.
Yeah, that's a great point. That's, restate it, because it also involves supplier variability, which we know is out there on a lot of, in the high-tech world especially. If you have better certainty on what you're going to build, that's helped that. And then better certainty on where it's going to be deployed, even better. By the way, I can't help to say that I was a former naval officer. It's not a boat, it's a ship. So, okay. And people that know me that know the naval officer can say, well, you let him say boat for him.
My sister's a naval officer as well, a naval chaplain.
Okay.
I guess I'll just call me Gilligan.
You've got these, what we might call safety stocks in the system. Mm-hmm. So keep on that subject for a moment.
Well, yeah, so, safety stock is always a function of what it's a function of variability, but also of the total lead time. So the longer the lead time, the more buffer stock you have. And over time, as you implement a demand-driven solution, as the lead times go down, as you remove system-based lead time, and there's actually a project we've got going on with One Network in conjunction with University of North Texas, which is to define what the theoretical minimums of moving something across the entire supply chain. Okay. The closer you can get to those theoretical minimums, the less inventory you have to carry at any stage in that node, which is basically how you optimize what your inventory levels should be. And not only that, but also because of being able to react in real time to what's actually happening by having visibility to what you've got coming in, you can optimize your customer service levels. So it's, the old paradigm of let's build enough so that we can keep our customer service levels at a certain
Right.
age. Well, they're at a certain level. Well, that made sense, but companies, I mean, cost pressures, competitive pressures are causing companies to look at, we need to free up working capital. One way to do that is let's lower our inventories.
Yeah.
Well, we don't want to lower our inventories because then our customer service levels will go down.
Yeah.
Well, guess what? We've, by having an underlying IT architecture that can support a whole real-time value network, we can do both. We can minimize your inventories and bring up customer service levels.
Okay, so I get the problem and the opportunity, and you touched on a network of some type of technology. Can you now go into what that is and how that helps in reduce lead times?
So what you really need is a network-based platform that's multi-enterprise, that can sit across multiple enterprises and have many-to-many network connections, which means that basically anyone on the network, you can choose to connect to them to become a trading partner, right? So this, if you think of this multi-enterprise platform layer that would give you visibility and allow through permissibility all of your trading partners to access information in real time, that gives you the visibility, foundation, and so forth to build upon. From a platform layer, as the cloud has emerged as a much more viable solution, and it's certainly starting to get adoption in the business community. So things like Facebook and LinkedIn and so forth. Obviously, you can see the power of those types of solutions. So if you can kind of think of, again, that the supply chain isn't really a chain; it's just a community of trading partners that are in a network fashion.
Right.
And so if you think of the Facebook or LinkedIn example, if you can put a cloud layer atop all these multiple enterprises and then simply represent that company once, so if you use the Facebook analogy, the company would basically onboard once. That's their company profile, right? And then they would then look at all the trading partners that they would want to communicate with, and the Facebook terminology, you friend request them and they give you back. And then then on top of this platform layer, now you can start taking the different supply chain and value network solutions across logistics and so forth, and use that to optimize and have that instantaneous data flow. So it's kind of the whole write once mentality versus having to have multiple instances and so forth.
Let me clarify trading partners, or ask you. Let's say I make tablets.
Okay.
I'm the tablet brand. I may have contract I may have contract manufacturers. I certainly have suppliers of components. I probably have logistics companies helping me move it from wherever it's being assembled or made. Then I'm probably selling it through, at least one channel would be through a retailer. So all those organizations are trading partners in our definition?
Yeah, absolutely. So, I mean, depending on where you are in the overall ecosystem, you've got, let's just take a brand owner or OEM. Their ecosystem from the demand partner side would be any of their channel partners. So, I mean, it could be direct via the internet, it could be through retail, through distributors and bars and so forth. So that would be kind of their, that'd be their trading, partners on demand side. On the supply side, it would be their contract manufacturing, the component suppliers, and basically anything that's going into the product that they're turning around and selling to their demand community. And then, of course, all the logistics that go within moving it between all the different points. So yeah,
and typically they all have different systems, right?
Yes. And so yes, that's you
so
bring up a good point.
How do they suddenly get on the same one?
Well, it was a great point that one of the critical things that they need to understand, or that everyone needs to understand, quite frankly, everyone understands this, but it just becomes a problem. Companies have gone and have spent large amounts of money implementing ERP solutions and other solutions that fit within what we call
themselves,
for their four walls, right?
Okay.
And that's great. I mean, in some cases, companies have had to deploy multiple ERPs within their company and so forth. But that doesn't give them that ability to communicate with any of their partners in a single platform. And so this, when I talk about this multi-enterprise platform, you can think of it as this layer that sits atop all the company's internal legacy systems,
Okay.
ERP systems, and so forth.
Right.
And then, actually, a good analogy we've heard from one of our customers is, you know, if you look at the supply chain ecosystem or the manufacturing ecosystem, the ERP system's like the elephant. It's big, slow, doesn't move very fast, but you give it information, never forgets. Whereas one network is the real time, it's a cheetah, where it can respond and you know, it responds on a dime, makes decisions quickly, and then synchronizes back down into that system.
Okay, Doug, thanks for that good discussion of the technology. Let me ask this question, because as we know, high-tech companies especially are not all about replenishment. There are new products all the time because product life cycles are less, and to keep advantage in the market, people, especially these days, want new products all the time: smartphones, computers, tablets, so on. So how does data latency get impacted in that process?
It's a real good point, because what we've been focusing on as far as reducing system lead time is taking a look at forward-most consumption and propagating that backwards. So what do you do when you're introducing a new product where you have no forward consumption at that point, right?
Good.
And so, you know, it brings up a very good topic around the whole integrated business planning process, which includes things like new product introduction, and then typically on the back side of the new product introduction is what it's replacing. So how is the new product introduction, and how is the other one going to be end of life? How can you forecast smooth and so forth? So,
Thanks.
and I'm sorry, actually, it brought up another point, which is very critical, is in the whole promotional planning piece.
Yeah.
And so, I mean, it would seem very obvious that in a promotional time, understanding what's actually being consumed is very, very critical.
Yeah, yeah.
And as part of that whole integrated business planning process, being able to plan for the different promotions and so forth is very critical. And then measure how those promotions actually did against those forecasts. And like I said, I want to get into the technology pieces that are necessary to reduce overall system lead time. But you know, if we go back to the discussion about having this multi-enterprise layer and what the characteristics needed there, then all these become applications that are built on top and provided as solutions or software as a service to customers.
Talked a lot about the demand-driven, the data latency, what it is, the technology. I think the viewers would appreciate having a little bit of an example. Can you walk us through what?
So yeah, you know, as you and I have co-authored the first paper, we've also co-authored this new paper on the effects of system-based lead time or data latency. As part of that, I built a model around the scenario of two different PCs being introduced into the market. And in the white paper, you'll see a nice little graphic, and actually, I think we can probably put it up as part of this presentation. But what it shows is that the basic scenario is that they forecasted both these different PCs to sell about equally. And what ends up happening is PC 1 in the scenario starts selling at a significantly higher rate. PC 2 is a slow mover. So in the business as usual scenario, what you'll see is that there's a huge amount of lost revenue opportunity because they didn't have the agility or the supply chain agility or flexibility to react to that chain or that demand that they didn't forecast.
Right.
So in in the case of the first PC, there was huge lost sales opportunity, and then going into month 2, they didn't have an inventory position proper to meet the next month's demand. In the case of the second PC, they had way too much inventory because they weren't reacting to what the demand was, so they kept building. I keep talking about the floating warehouse from China. They were building the wrong product, putting it on, and it was coming over, and even though the market didn't need it. So in the demand-driven scenario, what you'll see is that as in the case of the first PC is you recognize the trend in the actual demand that is significantly higher, that in a supply chain that's optimized and agile can react to that and all of a sudden start building the right product, stopping, and by the way, I did make it constraint-based, which you'll be able to see in the paper, but so we didn't go over the capacity of the factory. But instead of, still building to this forecast that turned out not to be based in reality, they started building to the reality, which was we need a lot more PCA, we don't need any more PCB. The bottom line on the demand-driven side was that there was no lost sales, and that going into month 2, the inventory position was almost matched perfectly. And had I actually run it more of a real time, in what could be done on a daily basis instead of multiple days, it would have shown that it would have been exactly matched. And then in the case of the second PC, because we recognized early that it wasn't moving, when you send that instantaneously back to the factory, they stopped building that. So now instead of, what's being brought over, including A and B, now it was a bunch of A coming over. So, of course, there was no lost sales because there was too much inventory. But going into the second month, the inventory position was almost perfectly matched to meet the demand for the second month. So, I guess the moral of the story is the earlier you recognize that, the more accurate you are into telling your manufacturing what to build, and then the more options you have as that inventory is deploying forward as to where you put that to make sure that it meets the actual demand.
Yeah, and the numbers do prove that out, because the case study is based on some reality about what happens in the supply chain, and you can see it.
Oh yeah, absolutely. I wanted to actually show you some real life examples, or at least a real life example of a major consumer products company and a very large retailer, and the types of results that they saw. So it's really a testament to what we have said. At one point, the industry average was roughly 60 days from raw material to shelf. In this company, they brought it down to as low as 20, which has had the effect of lowering their inventories by 30%. And it's also had the effect of lowering the retailer, the tangential effect, or the additive benefit to the retailer having inventories for that customer reduced by up to 50%.
Wow.
Now, and the interesting thing to to show in this slide is that the fill rates, or what was the customer service level, what was on the shelves at the time. You can see it's kind of varying pretty well. It's varying over time, and as they've implemented, and once they went live with the demand-driven strategy, not only did the service level to go up to over 99%, but the variability of that stayed between the 90 and 99, or 99 and 99.5. So it had the huge benefit of reducing costs, increased service, and also decrease the variability of what was available.
Yeah, it's very impressive. And as I think about it, how to suggest people move forward, when we do supply chain assessments, basically as is, what's the current state? We always want to measure time, cost, and quality. typically we can measure the cost, the quality, meaning service levels and so forth, and accuracy. Time always gets measured and just sits there. It doesn't really get reduced. So now we've got the technology to actually reduce time, just like we do cost, and just like we improve quality. So it's very powerful. And that's what I was going to suggest for the viewers. You know, when you bring the right technology into play with the right business processes, amazing things can happen, as you said, Doug. And we can also do things like postponement and personalization, and so much can be done with dealing with data latency and so on. So our suggestion for moving forward is to look at your supply chain in terms of the time, cost, and quality, current state, and make that assessment of how much time is it actually taking through the various steps, as Doug explained, from supplier to customer, and look at that and try to measure what's actual, that's physical, well actually what's physical, and what's system,
Right.
which equal, sum together is actual. Get those measures and then have a look at what we can do to reduce that system lead time, because as Doug pointed out, it's in many cases the same as the actual lead time.
Absolutely.
And in some cases more. Yeah.
Yep.
So we said we would discuss demand supply chains and reducing lead times, how lead times affect supply chains, how cloud and network technology can be employed now to really create so much opportunity. I think we did that. We discussed, we provided, when you went through the anatomy of lead time, what really does make up lead time, which I think is really important for people viewing. You talked about the new technology, and then you gave a couple examples, which is really good, of the power of this technology employed properly. So hopefully people will want more information. So for more information, we refer you to our joint paper, and you see the link on the screen to that. And we also refer you to either of our company websites, both One Network Enterprises and Tompkins International websites. And hope you enjoyed the webinar and this video cast, and let us hear from you. Thank you very much.
Thank you very much. Yeah, thank you, Gene.
Thank you. Good.